Good afternoon to you. Myself Jitendra Kumar and taking power electronics for the electrical engineering students. In the previous lectures, we are discussing all the various parameters which are associated with the SCR, and now we are discussing about the SCR ratings. SCR rating means whatever parameter will be associated with the SCR while we have to use it in the case of manufacturing or designing any circuit which are related to the SCR or related with the application part of SCR, then we are using these type of ratings. So on these types of ratings, and we will discuss in detail about the various parameters which will be important for under this heading. There will be the various parameters are associated like Harrister rating or SCR rating are very much required for operating it in a safe zone. The reliable operation can be done when a thermistor does not violate its voltage and current rating during working period. The thermistor or SCR may have several ratings such as voltage, current, power, turn on time, turn off time, etc. Generally, these ratings are specified in the data sheet given by the manufacturer. And next rating of the SCR is the anode voltage rating. This rating gives us a brief idea about withstanding power of a thermistor in forward blocking made in the absence of gate current. Next parameter is the peak working forward blocking or forward off state voltage, which is indicated by the DWM. It specifies the maximum forward voltage, positive voltage that applied across anode and cathode that can be withstood by the SCR at the time of working. So this will be the maximum voltage which will be applicable during the operation time of a SCR. Next is the peak repetitive forward blocking voltage (PRM). It specifies the peak forward transient voltage that a SCR can block repeatedly or periodically in forward blocking mode. This rating is specified at a maximum allowable junction temperature with gate circuit open. During commutation process, due to high decreasing rate of reverse anode current, a voltage spike is produced, which is the cause of VDRM generation. Next is the peak non-repetitive or surge forward blocking voltage (VDSM). It is the peak value of the forward transient voltage that does not appear periodically. This type of over voltage generated at the time of switching operation of the circuit breaker. This voltage is 130% of VDRM, although it lies under the forward breakover voltage. And the next parameter which is associated with the SCR is the peak working reverse voltage (VRWM). It is the maximum reverse voltage anode is kept at negative with respect to the cathode, which can be withstood by the thermistor repeatedly or periodically. It is nothing but peak negative value of the AC sinusoidal voltage. Next parameter is the peak repetitive reverse voltage (VRRM). It is the value of transient voltage that can be withstood by SCR in reverse bias at maximum allowable temperature. This reason behind the appearance of this voltage is also called as VDRM. Next is the peak non-repetitive reverse voltage. It implies the reverse transient voltage that does not appear repetitively. Though this voltage value is 130% of VRRM, it lies under reverse breakover voltage or forward on state voltage drop. This is the voltage drop across the anode and cathode when rated current flows through the SCR at a rated junction temperature. Generally, this value lies between 1 to 1.5 volts for a SCR. Next will be the forward dV by dt rating. When we apply a forward voltage to the thermistor junction J1 and J3 are forward biased, whereas junction J2 is reverse biased, and hence it acts as a capacitor. So due to a leakage current flows through the device, this value of current will increase with the value of one thing which we have to keep in mind that voltage value is not the reason behind flowing of leakage current. The reason is the rate of voltage increasing. The value of capacitance of the junction is constant. Hence, when increases to a suitable value, that leakage current occurs, an avalanche breakdown occurs across junction J2 takes place. This value of in called forward rating, which can turn on the SCR without help of gate current. In practice, it is not suitable to apply a high due to high temperature malfunctioning of the SCR. Next parameter is the voltage safety factor of SCR is indicated by the VSF. It is described as the ratio of peak repetitive reverse voltage to the maximum value of input voltage. Next parameter is the finger voltage of SCR, VFV. Minimum value of voltage which must be applied between anode and cathode for turning off the device by gate triggering. Generally, this voltage value is little more than the normal on-state voltage drop. Next parameter is the current rating of SCR. We all know that a thyristor and say the SCR is made of semiconductor which is very much thermal sensitive in nature. Even due to short time over current, the temperature of the device may rise to such a value that it may cross its maximum allowable limit. Hence, there will be a high chance of permanent destruction of the device. For this reason, current rating of SCR is very essential part to protect the SCR. Next is the maximum RMS current rating, IRMS. Generations of heat in the device present where resistive elements are present in the device. Resistive elements such as metallic joints are totally dependent upon RMS current as power loss is I square R, which is converts to heat. Hence, cause of temperature rise of the device. Hence, IRMS rating of SCR must be a suitable value so that maximum heat capability of SCR cannot exceed during the running condition. Next parameter is the maximum average current rating. It is the allowable average current that can be applied safely such that maximum junction temperature and RMS current limit cannot be exceeded. Generally, manufacturer of SCR provides a characteristic diagram which shows I average as a function of the K temperature IC with the current conduction angle phi as a parameter. This characteristic is known as forward average current D rating characteristics. Next parameter is the maximum surge current, ISM. If a thyristor operates under its repetitive voltage and current rating, its maximum allowable temperature is never exceeded. But an SCR may fall into an abnormal operating conditions due to fault in the circuit. To overcome this problem, a maximum allowable surge current rating is also specified by manufacturer. This rating specifies maximum non-repetitive surge current that the device can withstand. This rating is specified dependent upon the number of surge cycles. At the time of manufacturing, at least three different surge current ratings are for different durations are specified by the manufacturer. For example, ISM 3000 ampere for half cycle, ISM 2100 ampere for 3 cycles, ISM 1800 ampere for 5 cycles. A plot between ISM and cycle numbers are also provided for dealing with the various cycles current. Next will be the I square R rating of SCR. This rating is provided to get an idea about over voltage cycle power of a thyristor. The rating in terms of I square R is the measure of energy that can be handled by the thyristor for a short while. An electrical fuse I square R rating must be less than that of thyristor to be used to protect it against the higher supply. Next will be the di by dt rating of SCR. While SCR is getting turned on, conduction stays in a very small area nearer to the gate. This small area of conduction spreads throughout the whole area of the junction, but if spreading velocity of the SC of the charge carriers will be smaller than the local hotspot may arise nearer to the gate, which may destroy the device. To overcome this problem, a maximum rate of rise of current is also specified during manufacturing of such devices. Next will be the latching current of the resistor. This is the rating of the current below which the SCR cannot be turned on even the gate signal is applied. That means this much anode current must rise to turn on the device. The gate pulse must be continuous until anode current is greater or equal to latching current of thyristor. Otherwise, the device will fail to be turned on. Next parameter is the holding current of thyristor. This is the rating of current below which the anode current must fall to turn off the device. Next parameter is the gate current to trigger. This is the value of gate current below which device cannot be turned on. This value of current is specified at a particular forward breakdown voltage. Gate triggering voltage. This is the value of minimum gate voltage must be acquired by the gate circuit. For proper turn on of the SCR, this voltage value is also specified at a particular forward breakdown voltage similar to IGP. Non-triggering gate voltage. This is the maximum value of gate circuit source voltage below which the device must be in off state. All unwanted noise signal is must die under this voltage to avoid unwanted turn on of the device. Next parameter is the peak reverse gate voltage. This is the value of maximum reverse voltage which can be applied across the resistor and between the cathode and gate. Average gate power dissipation. This is the value of average power dissipation which cannot be exceeded by a gate circuit or a gate current pulse wider than 100 microseconds. Next parameter is the peak forwarded gate current. This is the rating of maximum forward gate current that should not be exceeded to reliable and safe operation. And these are the various components which will be associated in SCR, and we have to just take care about the rating of the SCR while we are using or manufacturing any device or application which will be using the SCR for a operation. So characteristics, so as the characteristics are important for the SCR operation, similarly the rating of different parameter with the accuracy is the most important thing for the SCR. Now this will be the end of the lecture. Thank you.